So we are going to start out with a little talk about brazing since we have been covering fusion welding before. We're going to talk about some alternatives to fusion welding, brazing being one of them. So brazing is, again, one of the alternatives to fusion welding. What is it? It's this process of joining two or more pieces of metal together through the use of a filler metal. So typically you'd have kind of an inner joint and an outer joint. Usually when you're brazing, you're going to be brazing something either inside or overlapping something else. Generally, brazing is less often done edge to edge. It can be, but you're looking for some particular shapes when you're going to be doing that. So yeah, you're using this what's called a filler metal, which is typically filling a gap in between these two pieces of metal that you're working with. Generally, the filler metal has a lower melting point than the metals that form the joint itself. It's usually a different kind of metal or metallic substance that you're using as a filler. You can use like a nickel, I think it's nickel copper alloy that we're using at work. Um, but generally it's some percentage of a couple of different metals. Your filler metal, more often than not, is some sort of alloy, some sort of combination of metals. The reason that this is different from fusion welding is that you're not actually melting the metals together. In terms of the two metals or three metals or however many metals that you're actually working with, you're not actually making them melt so that they'll flow together and recombine as a singular piece when they cool. So brazing, all of that joining is being done by the filler metal. So when do we do this? When do we braze? Generally, there are several kinds of metals that, for various reasons, they might not be really amenable to the welding process. Either they disperse heat too easily, so they're highly conductive for heat, or they don't coalesce well together, or generally they're just sort of resistant to this kinds of properties that would allow regular fusion welding to work. Um, if you've got two different types of metals, you're dealing with different melting points, and so the math can get a little bit weird in terms of how things are going to melt together and cool. Getting them both to the liquid phase at the same time so that they can coalesce can be very difficult. Um, Sometimes you're dealing with metals where the heat can actually cause deleterious effects or detrimental effects to the metals that you're working with, warping, any kind of sort of treatment that you don't want the metal to have at the joint, weakening of it maybe. Um, Generally, you want to try to braze when it's actually physically difficult to get to a joint place, or the geometry of the joint shape is weird, and so you're trying to get your tools around, and maybe it's a very precise joint. Brazing tends to be a bit more precise than typical fusion welding processes, so that's usually pretty helpful. And then when you really don't want to do this unless your joint strength doesn't have to be super high. So how does it work? And generally, you're going to be melting this filler metal with some sort of gas-oxygen mix. We use acetylene as our gas that we combine with oxygen to create the flame. Your filler metal is going to melt usually above 450 degrees Celsius, but you definitely want your heat to be low enough that you're not actually melting the metal, the copper, or whatever it is you're working with. So somewhere in that range between 450 Celsius and whatever the melting point is of the stuff that you're actually working with. Then the capillary action will essentially pull that filler metal, that liquid filler metal, into the gap in between the two pieces. So it's almost sucking it into that joint and filling it up, allowing it to flow. Generally, filler metal, once it's hot enough to melt, flows super easily, goes really fast. That capillary action is the primary physics concept that allows that to happen. Once the filler metal cools, the filler metal can cool stronger than the filler metal was before, because it's got this small area where the joint can actually move, and so by filling that small area, you're not giving it um, a lot of room to experience things like tension or compression forces that would allow it to break. So because it's constricted in that smaller space, it's going to be a much stronger metal in that way. And then it actually does do some metallurgical bonding in between the two pieces as well. What are the advantages of brazing? Again, as mentioned before, your metals don't have to be the same, so you're not dealing with trying to get those two melting points happening at the same time. It's pretty quick, so you can have a pretty high production rate. Um, you can do multiple simultaneous joints because you're not heating your workpiece to a point where it's really going to affect the chemical composition of the metals that you're working with. So you can do multiple joints and have that sort of buildup of heat. You can have more of that before it starts to affect your workpiece. So then generally it's cheaper to do because you're not dealing with as high heat, and therefore you're not having to generate as much energy to generate that high heat. You're not having to generate as much power for your power density as compared to the fusion welding. You can work with thinner metals again, but you're not getting it as hot, so you're not going to worry as much about deformation of the joint. Um, the heat affected zone generally has less problems associated with it. Spoke a little bit before about tempering or treating the metal in an undesirable way. Um, and then again, it's easier to reach hard to reach joints just by virtue of sort of the kinds of tools that you're going to be using in brazing. Some of the disadvantages that we face are reduced joint strength. It's not going to be as tough of a joint just because you're not using as much heat. The filler metal isn't as strong as the coalescence of two metals together. The joint itself can be weaker than the surrounding metals, so if you've got some forces that the metals may sustain, you still have to think about how much force can your filler metal actually sustain, because that's really the choke point for how much force you can allow one of these joints to experience. The working temperatures can get close to the melting point of the filler metal. So if you've got an application where you're running at like 400 degrees Celsius and your filler metal's at 450, you really do run a risk of weakening that joint because it really is dependent on that filler metal staying solid. And if it's pretty easy to remelt it. As a matter of fact, that's how we often get these joints apart. You just make it hot enough to remelt the filler and then pull it apart. So that's a problem if it is. If it's not, then it's not. Um, and then the fact that the composition of the filler metal is generally different than the metal pieces that you're working with. That can be an aesthetic problem, maybe, maybe not. Again, depending on what you're using it for, you have to kind of think about the composition of your filler metal because it will likely show up at any joints that you have. So what are some of these applications? It's pretty easy to repair things. You don't have to take something fully apart to get to the thing that you're trying to repair. Again, talking about moving in those tight spaces. So maintenance and repair is pretty good application for that. Electronic components. That's usually more of a soldering thing, but it can be done with brazing as well. If you're creating that kind of joint. Refrigerant and plumbing lines is something I use a lot for that in terms of joining copper. That's a strong enough joint for the kinds of pressures that you're going to be seeing in any applications like that, as long as you're not dealing with super high volume, which brazing generally isn't something you're going to do on a large joint anyway. Um, Joining tooltips to shafts or shanks. If you have a tooltip that you want to be added to a particular tool, but there's no way to say screw it in or otherwise secure it, you can braze it on there, and then when your tooltip breaks, you just unbraze it. So you have jewelry production, which we use brazing for that just because of the size. Typically, we're dealing with these sort of tight spaces and these really precise joinings of parts. And then they'll also use it for brazing auto body parts, which I struggled a little bit to find, but you can. I found what was called laser brazing, which they'll often use for sort of a more fine joining of the visible parts of um, the auto body. That's about it for me. I think David is going to take the second half of this. So best of luck, and we'll finish that off with the next one.